Well, welcome everyone. Thank you for being there. This late hour, I hope you're not too sleepy. If you are, then I hope I will wake you up with a fun presentation. So my name is Sébastien Duran. I work at EPFL in Martin Otoski's lab, and I'm working on Scala.js, which is a JavaScript backend for Scala, so that you can actually compile Scala to a JavaScript code. And the idea is that you can actually write in Scala for your web browser. So, by the way, these slides, they are an HTML page. You'll see that in action in a few moments. So, it all starts with JavaScript. Why JavaScript? Why are we bothering to do JavaScript anymore? Well, just because, as you well know, it's difficult to do web development without JavaScript. It's the only language that's basically supported on browsers, so you have at some point to have JavaScript code running. The problem with JavaScript, I think it's a very well acknowledged one, that it was designed as a scripting language, not as a language designed to scale to a large-scale application development. Anders Heisberg, the guy who did TypeScript, makes a very good point of it. I won't elaborate on this. You can, on the TypeScript webpage, you'll have a wonderful presentation giving you all the details. So it has become common to want to generate JavaScript from some other language. And other people have done that before me. Grit and Scala Grit, big framework, CoffeeScript, Dart, TypeScript, slightly, well, just more lightweight layers on top of JavaScript that help you with either syntax or classes or even some rudimentary type system. AppScriptem, which compiles C, C++ to LLVM to JavaScript, kind of weird thing. JS Scala, that's a DSL to embed JavaScript trees in Scala. Well, it's all over the place, and that's why I dare to say that JavaScript is now the assembly language of the web. Some people will disagree, I know, but yeah, I believe it is true. So, we have yet another approach, Scala Days. We know how Scala is cool, and we want to do the same thing with Scala. So Scala is a scalable language, so you can use it to develop big applications, and thanks to Scala.js, you can compile it to JavaScript, really. And it can interoperate with JavaScript libraries, as I will demonstrate. So what does it look like? Okay, this is JavaScript code. I'm not very proud of this. These two slides. I have. It took me a few hours to decide which code I was going to present first, so that I could highlight why Scala.js is interesting. And it turns out that, well, it's supposed to be very interesting with large applications. And I have one slide to make a point, so it's quite difficult to find a good snippet. So I ended up looking in Stack Overflow for a question about JavaScript, and I found this one, which is supposed to parse the query string of the browser. So this is JavaScript, and this is how it looks like in Scala.js. You'll find a few funny things. First, you can access the document thing, which in the global namespace. You can fetch location.search substring split. Then you have, via an implicit conversion, this method asScala_array, which will turn that JavaScript array into a Scala array. You can use for comprehensions. You can use, typo. It should be just args.toList, you can use for comprehensions. Inside that for comprehension, you can still use that decode URI component, which is a method of the global namespace. Use the same trick again, use pattern matching on the array deconstructor, and then use all kinds, well, it's Scala, and it's JavaScript. You have both. So let's make some fun. I told you these slides were an HTML page, so I'm actually going to run Scala.js code inside my web page, which is my slides. So this is the hello world of Scala.js, simple object, top-level object with a method, and it calls println. So let's run that. Of course, you won't see anything because it displays that on the console. So let's show the console. Yeah, okay. Takes a little bit of time. So there you go. You have this hello world nicely displayed on the console. Great. What does this? So it's, of course, now it's too small. So this is the code that is attached to the button. It's JavaScript code, and it invokes Scala.js code. So through the SJS global variable, which stands for Scala.js, you can access the global module, which is examples.hello.hello-world, and call the method say hello with println on it, and that will trigger the println inside, which is rewrite to the console.log method. Well, I have a couple more versions of that hello world now. So this one is directly using console.log. So instead of using println, we'll simply use js.dynamic.global, which represents the global namespace of JavaScript. And on that, you can call anything. So you can call console.log, giving it a string, and it will basically do exactly the same thing. Turns out that there is a funny thing here. If you look at where does this code from, does this call to console.log from, you see that it comes from hello-world.scala. And if I click there, I'm right in debugging mode to my Scala code.
Is that activator that we're seeing in the console that you're in, or that you're...
It's Chrome. It's just a fairly obsolete Chrome version.
So that's not a plugin to actually see the Scala code in there?
It's not a plugin. It's just Chrome. It uses source maps.
Now, you can keep that from happening in the browser too, though, right?
Yes, of course. You just yeah, sure. you just don't link the source maps, and you won't have that.
Very nice.
Can we see the JavaScript that generates not the Scala, but the version of the JavaScript that can generate?
Yes, I can show you that. This is the pretty printed version. And the one that you see but there are other things in this file. It's the whole presentation code is there. So
I think he just wanted to see view source in your browser console just for the hello world.
yeah, but by default it would. Okay, there it is. It's there. So this is the version that calls println, and this is the version that uses console.log.
So you eval in, I guess, the println?
The println, it's a method of predef, and in predef that calls console.out.println, and this one, through several more layers of indirection, ends up in the console.log. So I said I was going to have a couple more. So this one, the next one, sorry, uses alert. Yay, great. Okay, so this was about the not fun part. This starts to be fun because we're gonna use DOM. So I can use a document, use it to create an element. Currently, there's a problem with assigning to a field of a dynamic JavaScript thing, but it's going to be fixed at some point. And this just manipulates the DOM and adds that hello world there. Well, another one with some input. Okay. So you see that using get element by ID, fetching the value, etc., etc. Same thing. I won't expand more. Another one which is slightly different. The previous one was fetching the value inside the Scala.js code. The next one fetches the value in the JavaScript code that is calling the, and so it gives an actual parameter to the JavaScript, to the Scala.js code. So yeah, actually SD stands for Scala Days and for Sébastien Douran. If you are super attentive, you might have noticed that this method is called say hello with DOM input, and this method is called say hello with DOM input. It's the same object, same method name. One has a parameter, the other has none. It's one same code for the presentation, so this is an overloaded method. And from JavaScript, it uses dynamic dispatch to find the right one. Okay, well, nobody uses DOM anymore. We all use at least jQuery, if not Angular.js. So I have a very next to last one, which uses just jQuery, calls the method val, chains method calls. Well, nothing really. But then, who's actually binding code to the buttons manually in JavaScript? No one does that anymore. You have your JavaScript that is building your UI and actually uses, for example, the click method of jQuery to bind the code. So here it is. I can just have my Scala.js code building, fetching the button, calling the click method, and giving it a lambda. And it just turns out fine. That's all. You have your lambda that is automatically transformed into a JavaScript lambda and given to JavaScript. So that was for the hello world. So, tiny little bit trick here. Scala is statically typed. JavaScript and its APIs are dynamically typed. So how does it work out? Well, it turns out all the examples I showed until now are dynamically typed. So when I write this, I have jQuery, I fetch it from the global scope, and I receive a JavaScript dynamic thing. And with a JavaScript dynamic thing, I can do anything. I can call any method, I can fetch any field, I can modify any field, and I can even call it using the apply notation. And well, it will just accept happily any JavaScript value as argument, and will return another JavaScript dynamic thing on which again you can call anything. So, but okay, that's fine for if you have but a few interrupt with JavaScript. But well, at some point you want to have all the statically typed goodness of Scala. So let's have some. Basic idea is that first we will actually type JavaScript. So there is a class hierarchy, fairly straightforward. You have JS any, you have subtypes, number, boolean, object, and string. And under object you have all kinds of things, including the functions that are with type parameters, of course. And you can use that. You can also define your own. And you can, for example, define the types for jQuery. So on your right, you have the global object jQuery, which is defined as a top-level object in Scala that extends JS objects. And you define the method just like you would. Just don't give a right-hand side. Don't tell the body. Just put triple question mark or something. So you can define the apply method, which takes anything as parameter and returns a jQuery, which is the trait on the left. And with this, you have the overloads of HTML, the getter, the setter. You have same thing for val. You have append. And you have also parametric functions like click, etc., etc. So if we have this, how do we use it? Well, exactly with the same code. It's exactly the same thing, just now it's statically typed. Because it has in scope the jQuery object, which is the object jQuery, and it can check that it has an apply method, etc., etc. So how do we tell that it's actually statically typed? Run it first. Okay. How do we tell? Well, because if we mess up with something, for example, here I've misspelled the HTML method as HTL. Now I have a compile time error. Great. Other thing, I can omit the parameter to the HTML. Suddenly there's another overload which returns a string and not a jQuery, and so it complains that I cannot give a string to something to the append method which expects a jQuery. So nothing surprising here from a type system point of view. It's just that it's a JavaScript API and it gets type checked.
That with overloads, so define in your jQuery trait the fact that maybe append does actually work with strings, but not with like numbers.
What do you mean exactly? Can you rephrase the?
In real jQuery, you actually can pass in a string. That's just fine. It just interprets it as HTML. So let's say I'd like to express that in the API and have an overloaded append, one that takes a jQuery, one that takes a string. Will that work?
Yeah, sure. You can define overloads and it will type check the right overload, just like it with Scala overloads. So that is about compile time errors. What about runtime errors? Okay, here it type checks. It's just that I have forgotten the greatest sign in the call to jQuery if it's less than p, and I have forgotten the greater than. So if I run it, well, that's the magic of JavaScript. It just won't tell me anything because. But we get, once again, once it will have started in a few seconds, thanks. If we actually open the console, we see that we have an uncode error. Well, it's somewhere inside jQuery that won't help me much, but I can use this setting there to post an exception, and I will just retry that thing. And now I get a break. Well, it stops on the error, but that's the jQuery code. I like to see where does that come from. Well, there is a call stack. If I skip all this jQuery thing, I eventually end up with this hello Scala. And I find my Scala code, which was responsible for the error. You can also use breakpoints and use step-by-step execution, etc. Well, that's you have all this debugging goodness. Yeah. So I said that you had to somehow provide the type information if you want them. So that's how it gets done. So you define here an object jQuery, the extends.js object. That's some compiler magic to tell it that's a JavaScript top-level object. An apply method. And well, you just define usually traits in Scala code without right-hand side. And you can just declare pretty much everything. So this is for jQuery. This is for a very small portion of the DOM. Same thing. There was something special. Yeah, you have, for example, the var inner HTML.string, which is a string. So if you have a var, you can select and update it. With the typed version, it works. It's only the untyped version that doesn't work. Okay, so do we have to write that by hand for all the JavaScript APIs that we want to use? Well, yes and no, because it turns out other people have done that before. And a very good example of a language that has this is TypeScript. And actually there is this project, Definitely Typed, which gathers and aggregates lots of type definitions. And I'm working on it's almost done, but it's not not ready yet, but you can actually import these type definitions from TypeScript right into Scala.js. So we don't have to write that by hand again. We can just reuse what others have done before. Okay, so I was telling that Scala.js can call JavaScript, but how can JavaScript call Scala.js? I have just this one example with a bunch of overloads of a single method foo, one with 0 parameter, one with and 4 with parameters, an int, a string, an any, and a parametric version with a sequence of A. And below you have JavaScript code that calls it. So you can call o.foo, o.foo5 with a string. With this should be improved the way you can instantiate a Scala.js class from JavaScript. But currently this is how you can instantiate a tuple2, for example. And finally get the nil global instance, call the method colon on it and give it false. So if I run this, well, of course you get the expected result. It's left as an exercise to figure out why this is correct. So, Scala.js lets me write JavaScript code with Scala syntax and some static typing. Okay, cool. What's the point? Well, the point is all the usual Scala goodness, of course. This is a small application I have done as a demo. It's around 250 lines of Scala.js code. And it just uses HTML5, the canvas, all kinds of collection methods, pattern matching, interop with the DOM, jQuery and whatnot. And you can actually play this. So if you don't know, it's a reversey game, also known as Othello. Well, just for fun. So Scala.js actually supports all of Scala syntax and all of Scala things, classes, traits, case class, type system, well, whatever you like most about Scala, you have it in Scala.js. What you don't have is interoperability with Java. But you get interop with JavaScript instead, which is fair. I actually have still quite much time, so I will actually show you some portions of the code of the previous reversey example. This is my model, a class square with fields, vars, getters, setters, a toString method. It's a little bit. Create a two-dimensional array of such squares using array.tabulate. Use the collection methods on arrays like flatten. You have the player, which is actually a sealed trait with case classes, with case objects. This is the code that reacts on the click method on the board using the jQuery click method, but this time giving it a lambda, which takes actually a parameter, which is a jQuery event, and it uses the click square method, which uses the collections and the for each and cons, etc. You have this pretty awesome for comprehension with lists, and this pattern matching with a fold, tricky fold to compute the score. It's not the nicest way of implementing this. It was just to make a point of using pattern matching. And this finally is the code that actually renders the board using the canvas API of HTML5.
Just to make sure I follow, so you've put in as a special case the canvas API as a strong component.
Yes, no. Well, I mean, it's just a JavaScript API, so I can use it either in an untyped way if I don't want to give the type information, or in this case, I have provided the type information.
Okay, yeah, I just want to make sure. So when I see like context object app, or that context object, wrapped object,
This, yeah, it's.
that's a first-class citizen.
Yes, every JavaScript type is a first-class citizen type in Scala.js. And it can have type parameters, it can be used inside type parameters, it can everything. Yes?
So in theory, you either have or could do wrap WebGL in a trait and then offload some of the computing, some of the rendering other than the visual rendering to a cluster of actors?
Yes. In theory, you can interact with WebGL, with WebSockets, and so you could have an ACA front end, for example, communicating with, I don't know, your remote backend using also ACA. Yes. Yeah.
So you said you could use all the Scala code. So are you emulating all the Scala numeric types then? Because JavaScript only got doubles as far as I know.
Yes and no.
Now you're getting tricky.
It's a good question.
Repeat the question.
Yes, so the question is, given that JavaScript has only doubles, what do I do about all these numeric types? And so what I do is that they are currently all encoded as doubles. And operations are double operations, except for division with integers, which is truncated so that you actually get an integer. But they are not, they don't wrap. So they will keep growing below their range. But at some point, I plan to actually implement longs in the correct way, because all values of a long cannot be stored in a double. So in that respect, I intend to follow the GWT way of implementing this.
You said you cannot use Java. Does it mean any Java library thing? So I can imagine that many of the Scala library is dependent on Java library things, like a big int. Maybe that's not a good example, but like
Okay.
regex.
Yeah, so the question is, well, of course, the Scala library uses some of the Java library, and I said you can't use Java. So what I do and what is to be done for Java libraries is rewrite them in Scala.
Rewrite them or just wrap them? Like,
Rewrite them, because if you wrap them, you still depend on them.
why wouldn't they work? I don't understand.
Because they're Java bytecode, they can't run in JavaScript.
I thought you meant I thought you meant you couldn't run Java code on the server.
No, so of course you can use Java code on the server. Here it's all about the client, right?
So you need the source code as long as the source code is available by Scala, you can do it.
Yes. There are many questions. May I ask that I finish the presentation? I have 3 or 4 minutes more, and then I'll take more questions, because otherwise I'm going to not be able to manage the time. So, little wrap up about the feature coverage. So it's complete Scala with the amendment of the semantics for integers and floats. It can call JavaScript libraries either in a typed or untyped way. We can import type description from TypeScript. We can even pass anonymous functions to JavaScript call, which is amazing, I think. And even more amazing, you can let JavaScript call you, including with overloading resolution. So what's the main issue right now? And this is going to... because it uses the Scala standard library, well, you have to compile the Scala standard library with Scala.js, and that yields 16 megabytes of JavaScript code after compression by Google Clojure's simple optimizations.
So that hello world was...
That hello world was 16 megabytes.
That's why when you open the console, you right?
Yes, because so just the runtime is pretty fast, but when I open the console, it tries to load all the source maps and the source codes and everything, and then it takes a lot of time. Just the runtime, from a browser perspective, it's pretty fast. Loading is under a second, so that's less than Gmail or any Google app that I know of. The problem, of course, is bandwidth. But we have only scratched the surface about reducing the size of that output code. So there are lots of things we intend to do to reduce that, and my aim is to go below 1 megabyte. If it's directly related, yeah.
Yeah. If I don't use Scala collections, does that number drop dramatically?
Right now, no, because you will still need some part of the Scala library, and so you have to include the thing, and it doesn't yet do that code elimination of these kinds of things. That is something we plan to address. Yes?
I'm sorry, I misunderstood earlier. I was under the assumption that this was like, being compiled on the server and then the JavaScript source is being sent to the client. Is the Scala file being sent to the client and then compiled using the Scala file on the client?
No. It's the compilation is ahead of time, and it is JavaScript code, and that code is sent to the client. It's big JavaScript
Can
code.
you persist it once you get it locally?
Yeah, of course, any browser will cache it, but it's not that tragic, but it's still tragic. So what we are going to do, in addition to reducing that code size, tooling supports. Right now I'm working on the SBT supports. Actually, this presentation code was compiled by a fork of SBT that supports Scala.js. IDE support. Then at some point I'd like to present next year at Scala Days an actual Scala.js REPL inside the browser, so that I'd like to compile the Scala compiler through, the Scala.js compiler through Scala.js, so that I get JavaScript code that can compile itself inside the browser. That's for next year. Keep in touch. At some point, we'd like some kind of UI DSL on top of whatever, be it DOM, jQuery, AngularJS. I don't know, whatever is a good idea. And then pretty big things, some integration with Play maybe, or with and the question asked earlier, the AKA implementation of on the single-thread environment that is JavaScript. That's not going to be easy, but I believe it can be done.
Oh no, I wasn't asking for that. I just wanted to be able to easily launch. I work remotely to do my dirty work on the server and make an Ajax.
Yeah, of course. You can do Ajax. That's trivial. You can do it right there if you.
I don't want to do anything in somebody's browser.
And then another thing that's really more research about it. It's exploring state-of-the-art typing systems for JavaScript somewhere on our. So yeah, that's all for today. So there was a question at the back there.
Have you implemented a parallel compiler here, or is it a plug-in to the existing compiler? Or how does all this work? I mean, there's a lot of what goes on behind the scenes.
Right. So the question is, what's the compiler? How was it implemented? Is it a parallel compiler or something? It is, technically speaking, the backend that is changed. So that all the earlier phases of the compiler, parser, namer, typer, all the transformation phases that get rid of pattern matching, lazy vals, etc., the same thing. And only at the very end, instead of emitting bytecode, I emit JavaScript ASTs that are then transformed into source code. So technically speaking, it's actually an application using Scala compiler, the jar, as a library. Yes?
How does like modularity and imports work? Like, I mean, can you dynamically load? Would you be able to dynamically load code from the server, like additional code?
Yes, there is. So the question is, what about modularity, imports, and I guess, well, packages and classes, and can you load them dynamically? To implement that, I have one global object, the SJS that you saw, which keeps track of all the registered classes that it could instantiate if need be. And on the first time that you want to access that particular namespace class, it will actually execute the class definition so that it registers it somewhere and then instantiate your object, and etc. So that thing could be here you have to pack them all together, register them at the very beginning, and then it can proceed. But it could be extended to dynamic loading from whatever internet source. Yeah. Yes, in front.
Are features supported?
Yeah, that's currently we don't have it, but that is something again that I plan to address. The project is fairly young. It started in February, so it's 4 months old. So, there was a question there.
Yeah, like a lot of people like to use things like _JS and things like that to do collections and whatnot on the client side. I imagine you don't have it now, but do you have plans to implement something like where the collections, instead of, I don't know how you're mapping things like for each and map down, but say like map my collections onto like _ collections and functions on _ functions, so on and so forth.
Right, the question is how about using, for example, _.js to implement the collections and anonymous functions or whatnot. It is a possibility, but I believe a better solution would be to write a sort of fork of the Scala library that is targeted at Scala.js. And that would be more efficient with this regard. But if that proves unsuccessful, then I will fall back on some leveraging of existing JavaScript APIs. But it seems better to me to keep in the Scala collection thing, because this way you can actually have some logic code that can be used both on the server and the client if you want.
I meant like keep using the standard Scala collections, but then down to
Okay, implement it down with. I'm not sure in that case that it would be more efficient than using simply the existing implementation. I don't think it would. Sorry?
You could introduce more bugs in your code.
And you could introduce more bugs.
JavaScript debugging.
Yes. Yes?
At Scala Days last year, there were 2 presentations on Scala to JavaScript compilers, and so now this is a third. Can you compare the 3?
Okay, the question is, last year at Scala Days there were 2 presentations about Scala to JavaScript compilers, and this is the third. Yes, it is the third. That's a difficult subject, compiling Scala to JavaScript. And this is indeed the end of many attempts to do that. The fact is that all other projects have somehow been abandoned within time, and in 4 months I have achieved much more than what every other attempt has achieved with however long they have worked on it. And I believe the results are pretty cool right now, and that it's just beginning. We have so much to explore with this, and I believe this is the right thing. It will work.
Any release date idea?
Any release date idea? I was hoping I could do an 01 for Scala Days. I just want to wrap up the TypeScript imported thing, so a few weeks for an 01. Then I don't know what will be the plan. Okay.
What are you using to test? How are you testing since you have the JavaScript?
What am I using to test? Good question. I haven't figured out a good way yet. It's difficult. I have to figure that out. I don't know yet how to do it properly. Yes?
What's impossible to write with the current ECMAScript specification? What is not possible to write with Scala.js with the current specification?
Okay, so the question is, what of Scala.js can't can't you actually compile given the current specification of ECMAScript? Arithmetics. Well, you can, but it would be so much of a runtime overhead that it's not worth it. Implementing actually the 8-bit, 16-bit, 32-bit, and 64-bit of Scala. But I don't think it's a good idea to do that. Why do you have these numeric types in Scala? Because it was geared at the JVM, which has these types. And Scala.js is a slightly different language that targets JavaScript. It does not target the JVM. So its numeric types are geared at JavaScript numeric types. I believe this is the right choice. And obviously, Git designers thought that too. So, does that answer your question?
More or less. I mean, for example, threads, you could use web workers to do it.
Oh, wait, yes.
On the screen, you could use Canvas and like what you cannot do that you could do.
Okay, so this is more like, it's not really about the language, but about the Java standard library and what it offers as a system layer. I don't know exactly how much of it can be done and what can't be done yet. I believe that even files, there is now with HTML5 some local storage support, so you could implement files this way. Threads, threads. That's a difficult thing. There are web workers, yes, but I haven't figured that out yet. That's going to be part of the Akka integration thing. Figuring out the thread thing. Yes.
What's the compilation speed like compared to compiling to bytecode?
Same thing. So the question is, what's the compilation speed compared to the real Scala compiler that compiles to bytecode? It's the same thing.
It's exactly the same time, or
it's not exactly the same time, but I don't. Well, on the large amount of the time that takes for Scala to compile, I don't see a difference. I haven't actually measured it, but I don't see the difference. Yeah, the thing is that all the bottlenecks of the compiler are before the backend. The backend has its optimizer, and I have this source code emission, and these apparently somehow level out each other. Yes, at the back, very back.
What is this end up spitting out? Just one JS file or multiple files, one per Scala class?
The 16 megabytes. It's a one big JavaScript file.
So if you run it on your own code base, it produces one big file that includes a library, and that file and everything else was a library like a separate JS file.
Yeah, so the Scala standard library and the subset of Java standard library and some of Scala.js own standard library are compiled into one JS file that you can reuse with your application. And then when you do your application, the Scala compiler, the Scala.js compiler itself emits one JS file per class. But then usually you post-process it with a cat utility, and you also cat the source maps in a smart way. I have an SBT function that does that. I have to release that as a plugin too.
So you could split it up a little bit more elegantly.
Yeah, of course you can split it up. And if you can figure out what parts you actually use in your application, you can just deliver them, and it will work. But if you don't figure it out accurately at runtime, you'll have problems. You had a question?
I was just going to ask about what is the support from EPFL and or TypeState as far as do you have how long are you at EPFL?
So the question is what's the support? What's the support from EPFL and TypeSafe, and how long am I going to be at EPFL myself? I'm just starting. In September I will begin this PhD, so I'm there for 4 years. And it's supposed to be a main topic of the thesis. So And if it turns out to be really pretty cool, I believe that TypeSafe will somehow keep the thing running at some point. Yes?
I think it would be really cool if you could sort of change the jQuery object into a macro, which is able to load your web page at compile time and turn potential jQuery selector errors into a compile time error. So you don't actually need to run your whole application. You would just be able to get everything before you deploy.
What could possibly
the statement is, what if you could turn jQuery into a macro and actually expand your UI and everything at compile time and figure out the errors and the result and already have your application ready to be deployed? And there was a comment, what could possibly go wrong? What was it? Yeah, what indeed could possibly go wrong? It's a pretty tough remark. It could work out. Well, the thing is, right now it won't support it for some reason, but you could use the Scala macro with Scala.js. You just have to compile them as Scala code, not as Scala.js code. So you could re-implement the jQuery thing as a macro. I don't know what good it's going to be for. It's probably worth investigating, but I'm not sure I will do that. But if you want, you're welcome. I probably have time for one more question. Yes?
What's the largest application written in it so far?
That reverse example. And that presentation, which somehow is a Scala.js application. I have done them myself just 2 days before I had to do my first demo. So, but I believe you can write a fairly large piece of code now already.